Great. Thank you so much. And brilliant intro. And welcome to the webinar. My name is Spencer Hardcastle. I manage customer advocacy for Fusion 360. And as you've already heard, we're going to deep dive into some of the tips, some of the tricks of how to be successful with the Nesting and Fabrication extension. So let's dive straight in. We're going to touch on nesting basics. So a little bit of a refresher, I guess, for those that maybe aren't as familiar with what nesting is, how it works, why we need it, what the purposes of it are. We'll touch on Fusion 360 from a relatively high level, just to level set on an understanding of what the product is now and where it's going in the future. Talk about extensions. Why do they exist? Why not just throw everything in the core offering? And what extensions exist and how you can add value in a flexible and approachable way to Fusion 360's core offering. Then we'll dive into the meat of the session today, which is going to be all about tips and tricks. And finally, we'll do a recap, summary, and then a big Q&A session at the end. If anybody does have any questions as we're going through, please use the chat, use the Q&A. We got Marco manning the chat, and we'll be stopping periodically through the webinar to address those. And hi and welcome to everybody joining on YouTube as well. It's great to have you. So with that, just the first little question to everybody, I guess. Let us know in the Q&A, in the chat, if you're on YouTube, in the comments. Have you used Fusion before? Have you used the nesting extension before, more importantly? And what do you use Fusion for? I'd love to know. Okay, with that, a little bit about me. So as I said, my name is Spencer Hardcastle, and I manage customer advocacy. So when I always say that, everybody says, well, what does that mean? Well, what me and my team do is look to bridge the gap between the development side of Fusion 360 and the customers, bringing in that customer voice into the development conversation to ensure that we're doing what's best for the customers in terms of development, in terms of future progress. And also making sure that what we are developing works for a start, but also has the best intentions of the customer at the center of it as well. So exciting times. I've worked for Autodesk for coming up to 9 years. I actually came on board through the Delcam acquisition. I used to focus on FeatureCam a lot before transitioning to Fusion 360. And I've had multiple roles. I started on a graduate scheme, actually, and then transitioned to international support roles and process and product specialist before starting as a manager in customer advocacy. So exciting times, and look forward to many more years. Okay, with that said, let's take a little backward step and talk about nesting. From a high level. And what is nesting for a start? Well, nesting really is the process of maximizing efficiency. And when I say efficiency, it's basically twofold. It's time, and at the bottom line, it's money. And so what we're using nesting to do is to prepare assemblies, prepare 3D model geometry for manufacturing in sheet form, so in effectively 2D sheet form. And so what we're doing there is we're not only making it more efficient to manufacture, which is going to save you time, but it's also going to lay the componentry out in such a way that's going to maximize your material utilization, and while at the same time minimizing waste. Now, sustainability is so important in modern manufacturing, and I think nesting often gets overlooked as a really key player in helping to be more sustainable. So I guess bear that in mind as we're going through. You'll see how we can really start to use less in a shorter period of time, I guess, and use less material. So I mentioned already what it is, but effectively, in a nutshell, it's going from an assembled bunch of components to flattened geometry. So from the left to the right. Now, this is the geometry we're going to use throughout the session today. It's an audio stack designed for audio-visual purposes, and it's sheet metal predominantly. It's an interesting assembly because it's made up of different thicknesses, different materials. There's some prefabricated parts like the casters, the handle, and obviously all the fastenings and fixtures. So we can deal with all of that using the nesting and fabrication extension really automatically and really seamlessly. And excited to dive in for sure. So why do we need it? So why do we need nesting? Well, I've already mentioned it's about part positioning. It's about taking those folded, if you think about sheet metal, it's taking those folded pieces of geometry, flattening them out, and then laying them out in such a way to be as efficient as possible while minimize the overall cost. If you can lay those parts out in the most efficient way as possible, you're going to use less sheets, and overall you're going to save money and minimize costs. Fusion actually bakes in cost into the nesting and fabrication extension as well. So we're going to dive into all of that in detail, and stay tuned for more, I guess. So when it comes to, now we know what nesting is and we know what its purpose is. What industries use it? And there's three main ones. You've got sheet metal, which personally for me is the most industrial of the three. It's using sheet metal stock, aluminium, steel, the list goes on. And then typically those components are then bent into its 3D form and assembled together, whether it's with fixtures or welded or a combination of the two. Then you got woodworking, so that kind of fairly self-explanatory, the idea that you might be using a router, for example, to cut your parts out. It may be then to assemble on site, or you may ship it off flat and assembled at location. Woodworking as well, very popular. Signage as an example. And then lastly, cabinetry. So the idea of being as efficient as possible with a whole bunch of rectangular shapes for various different applications. And when I say applications, there you can see a few on the screen now. So we mentioned signage, that covers sheet metal, it covers woodworking. We talk about sculptures. There's a fairly famous sculpture in the Boston area. It's an owl, and its eyes follow you around as you walk across and around it. Let us know in the comments or the chat if you've seen it. But that was designed using Fusion 360 and especially nesting to achieve those results. Couple of examples of snow plows that we've seen, so things like barbecue trailers that you hook onto the back of your pickup, or snow plows, or enclosures for electronics is a very popular one. And then when we talk about cabinetry, the obvious ones you think of straight away are kitchens, bathrooms, offices, but then custom cabinetry as well for shelving units as an example, or built-in wardrobes as another. Often things like kitchens are a mixture of sheet metal and wood, and so that brings another level of complexity to the equation that you have to obviously take into account as well. So that was section one, a little background on nesting. Now let's talk Fusion. That's why we're all here, to learn a little bit more about Fusion. What we're going to do is just level set on what Fusion is now and where it's going in the future as we move through. So changes here, and it's happening right now, whether it's from new manufacturing technology or new techniques, all the way through to algorithms that really change the way you think about design. And so it's important that we take advantage of some of these change points. Now, there's a skill shortage. We're all there, especially when you talk about manufacturing on the shop floor and people with an understanding of really that trade. We see it time and time again that it's difficult to fill those positions. You've got rising costs. We're all feeling that, both professionally and personally, of course, with cost of living and inflation prices and things. And then supply chain volatility. The Russian invasion of Ukraine didn't do anything for the stability of the supply chain, of course. But there are industry trends that will allow us to capitalize on some of these challenges. So when we're talking about skill shortage, think about smart products, and smart products that change the way that we kind of interact with every part of the product development lifecycle. And we're even starting to see that trend on the shop floor too now with smart controls on machine tools and things like that. Processes aren't mutually exclusive either. So when we're talking about rising costs, we've got to think about digitizing processes. And as I said, those processes aren't mutually exclusive. You don't just design and make a product with one process or one product normally. So it's really imperative that these processes are digitized. That's going to allow us to maximize efficiency, especially when inevitable change occurs in that in those processes. And then when we're talking about supply chains, they're constantly changing. And it's really important that products and manufacturers adapt and adapt quickly to change, and maintain a flexible connection with their clients, with their customers. And that's where we're seeing the power of the cloud and leveraging that cloud connectivity piece. Not just cloud data storage, but also looking at cloud computation capabilities as well. And yet, despite all of those changes and the increases in demand, manufacturing still looks a little bit like this, a little bit antiquated. The experience maybe feel a little bit old-fashioned, with broken communication, right? Multiple file formats, manual systems, a mix of digital and analog, and pieces of software that don't really communicate. And software solutions that really operate in isolation like this create some significant inefficiencies between those processes. And they don't really adapt well to change, right? You change something in one piece of software, it's another file export, right? And as soon as you do a file export, you're creating a disconnect between one stage in the process and another. And as data is stored in silos too, and it's passed around, we've been there, right? Memory sticks, email, antiquated systems that cause some silos in data and definitely some disconnection. And so, but what we've done so far in this section, of course, is talk about the technology. And in our rush to talk about technology, we often forget about what's most important, and that's the people behind the processes. Those are the people that matter most. And so at Fusion 360 and at Autodesk, we're looking to put the technology at the forefront, right? To automate some of those non-value added tasks and really allow people to add the value where it matters most. So not replace the person, just put the technology at the forefront to allow that person to be the best version of themselves. And so our goal, as I said, is to build this single digital platform on which every discipline, every department can connect in a seamless way with a single source of truth across the entire supply chain, even including the end customer. So what this does, and our vision of Fusion and Fusion in the future, is that it helps break down silos. It allows businesses to become more agile, but it also gives you access to the next level. So automation between processes, some productivity gains, and it gives you that competitive advantage. And that's why Fusion exists. And that's why we built Fusion 360. It's not just one aspect of that cycle, that life cycle, it's all of them. And it allows Fusion to be a fast, a flexible, and a connected platform. So that's Fusion. That's what it exists. That's the pitch. That's why we're all here today. But we build on top of all of that with extensions. So Fusion 360 has capabilities in all these different realms, whether it's simulation or design or nesting or generative design even, or data management. The extensions allow you to go to that next level. And they allow you to go to that next level by extending your platform, which eliminates disconnected tools like we've spoken about already, and extends workflows with specialized technology. And it does all of this on a single platform. So it reduces that learning curve and allows you to effectively pick it up quicker. It simplifies manufacturing processes. So we're looking at, and this is especially true for nesting, improving operational efficiency by adding automation and optimized workflows through these extensions to increase things like manufacturing throughput and reduce the overall time to market. Like I said, especially true for the nesting and fabrication extension. And then, of course, you can access these extensions in a flexible way, whether that be on a day-to-day basis. Because let's be honest, you don't necessarily need the full level of complexity 100% of the time. And it's important that you can adapt your usage of Fusion when your business needs to adapt. And that is the core reason for an extension. It's about adaptability, but it's about having the capabilities to go to that next step and to access that functionality that allows you to give you that cutting edge. And so, like I said, you can access it on the day, you can access it on the month, or on the yearly basis. So we talked about the nesting world, we talked about Fusion and the extensions, and there's an extension dedicated to that too, and it's the Nesting and Fabrication extension. And what this extension allows you to do is effectively do what we said nesting was, right? It allows you to reduce your programming time by automatically laying out your parts. You no longer need to manually say, well, this part might fit there, and if I change that one, that could fit around there. It's all automatic. The algorithm takes care of itself, and you know that you're going to get the right result and the most efficient result. Multi-part and multi-component nesting is also available. So it's the idea that you don't necessarily just have to nest one Fusion design at a time. You can bring multiple different designs together, maybe from different families of parts or maybe different orders, to further increase your efficiency, but all importantly, reducing that programming time by nesting them together. Reducing cost. At the end of the day, it's all about cost, money, money, money. And when we were talking about reducing costs, it's all about optimizing your material yield. So bringing in those external components, thinking about orientation of parts and flexibility of orientation too, thinking about grain control, comparing different material selections. So we all know that sheets of aluminum or aluminium, of course, depending on where you are, come in different shapes and different sizes. Same for steel, same for any sheet stock. And so which one is more cost efficient? Is it more cost efficient to get a bigger sheet and use less of it? Or is it more cost efficient to get short, smaller sheets and use multiple? And again, the nesting and fabrication extension will tell you the answer to that. And then lastly, minimizing rework. So as we've already said, Fusion is this integrated end-to-end product development lifecycle platform. And so with the integrated design functionality, as well as then manufacturing in terms of laser, plasma, router, or water jet capabilities, and I'm only speaking about the 2D there, it allows you to go end-to-end. Design the part, nest the part, manufacture the part, all in a connected platform. And then it's associative. So if you change any part of the design, the nest will update automatically too. At this point, I'm going to pause. Marco, any questions in the chat? Any questions on YouTube?
I think we had one on YouTube, but we managed to answer that. It was on the cost of the extensions.
Okay.
And nesting. Yeah.
Great. If that is still a question that you'd like me to address it further along in the presentation, just let me know. Okay. Now there's one thing that we should talk about before we dive into these tips and tricks, and that is that Fusion does have some, in quotes, nesting capabilities in the core offering. It's called a range. And what a range allows you to do is nest or range parts from the current document, the document that you have open right now. And that's where that functionality ends. It allows you to arrange on a single sheet. And effectively what it is pick and click, right? You select the components you want to arrange, you select the area or the face or the sketch that you want to arrange it within, and away it goes. There's no thickness detection. There's no multi-sheet, as we already said. Whatever you click, wherever you click, that's what you get. It is associative, so if the model changes, your arrange updates. It features there in the timeline across the bottom of the design workspace too, but it does have some limitations, as we just mentioned. When it comes to cutting and fabrication, 2.5D cutting options are available, as well as a library of posts. Now, when it comes to the Nesting and Fabrication extension, we build upon that capability. As you would imagine with an extension, it needs to go above and beyond what you're seeing in the core offering. So I mentioned this already, but just to dive in a little bit more detail, you can nest parts from multiple documents. We've said it's all about being as efficient as possible with the material you have. And by bringing in external documents, that's exactly what you can be. Fill up the space, make sure your sheets are full, and away you go. When you do that, of course, it's really important to track those parts, right? What part belongs to what assembly? And one of the tips that we're going to talk about in a little bit goes a little bit of a way to answering that. And then we also detect material, we detect thickness, and we detect the quantity from the design space automatically with the extension. So it's looking at what material you've set: aluminum, steel, wood, maple, rubber, anything. Whatever material you set in the design workspace, we can consume that and then automatically apply a set of nesting defaults to that material. You can store that material in a library, and that library then can be shared using cloud libraries, again, the power of the cloud, with everybody else that works within that team. It's going to detect thickness. So whether it's 2 millimeters thick, 3 millimeters thick, half an inch, quarter inch. I apologize that I'm a millimeters guy, so the demo is going to be in millimeters, but the gist of the demo is the same. And then quantity. So if you've already built your assembly, you want it to take into account those quantities, right? If you've used 3 of a particular part in a particular assembly, treat them all as one, but 3 of them, right? You don't want to apply different settings or duplicate the settings, I guess, on all 3. So quantity detection is also very important. Now, when it comes to nesting, the Nesting and Fabrication extension allows for advanced part and material controls. So things like controlling the orientation in a little bit more detail. With the core offering, it's going to be the polar orientations: 0, 90, 180, 270. With the Nesting and Fabrication extension, you can unlock it down to a single degree, 360 degrees of fluid orientation control, if that's where you want to go. Advanced controls over quantities too, over filtering. So automatically filter out anything that isn't sheet metal. Automatically filter out all the sheet metal parts, just concentrate on the wood components. That can also be done. And then cost. Build the cost into the material library so that as you're nesting, you can start to get an idea of which workflow, which process is more cost efficient to you. Shared libraries of sheet stocks that, again, like I said, can be shared in your assets folder in Fusion 360 and shared across multiple users. So one person needs the knowledge and everybody in that hub can consume that knowledge. And then reporting is also very important, especially if the person that's cutting the parts isn't the person that programmed them or nested them in the first place. They need to know what they look like. They need to know where they're from. And comparison. Which method of nesting is the most efficient? Let's create 2. Let's compare them. Let's have a look at efficiencies. Let's have a look at cost. Let's make that decision. And then the benefits that you get from the extension when we're talking about cutting, when we're talking about fabrication: Dxf Export with layer mapping. Some machines just want a Dxf. They don't want NC code, and so it's important that we can meet those needs. Remnant cut geometry is also added automatically in the form of a sketch line. You drive your cutting tool along that line, and it creates more geometrically easy to store components or pieces of sheet stock in your factories. And then automation for setups and operations, automatically allowing you to effectively derive the setup from the sheet. And of course, what you get by doing that is the size and shape of the stock automatically and the connection between the two. So just like the previous slide, what this slide is effectively trying to say is there is some nested in the core product. And if all you need is single sheet and no control over orientation and only one document at a time, then the core offering is the one for you. If you want to be able to future-proof your investment and be able to go that next step with multi-document and more advanced features and functionality, then the extension is definitely the one for you. Any questions? I saw the Q&A pop up there for a little bit. I see the chat going. Marco, what's happening? Talk to me.
I think we're good. We had enabled the chat, so everyone should be able to use the chat now if you have any comments or questions. Sorry it wasn't set up right away.
No problem. No problem at all. Okay, so with that, let's dive in to the tips and tricks. We've got 5 for you today. And I say 5, there's probably more like 10, but I consolidated some of them together so we weren't jumping back and forth in the presentation. And the first one I want to talk about is prep. Prep. With the nesting extension, the more prep you do, the easier all downstream activities will be. The more prep you do, the less rework you're going to have to do later on. And when I say prep, what I really mean is the nest preparation dialogue that's found in the design space. So over in the design space, what nest preparation allows you to do is effectively say, I do want to nest this part or this component. I don't want to nest this component. So you see, we've got that example that we talked about before, right? The handle here, that's a component that I'm going to buy off the shelf. Don't need to nest that. The casters, don't need to nest those. That I'm going to buy those off the shelf too. All the fasteners that hold all of this componentry together, I don't need to nest any of that either. So what I mean by prep is, let's do that nest preparation in the design space. Let's choose the components that, yes, I do want to send to nesting. No, I don't. And by doing that, what happens is further downstream is you don't end up with situations like this. So in this particular example that you're seeing on screen now, I've done no nest prep whatsoever. Haven't touched it. And let me tell you, it takes a long time. There are a lot of components in this assembly here. And by doing nothing, what effectively happens is the first time you press component sources or the first time you open up to try and create a nest, behind the scenes is calculating the nestable shape, the nestable geometry of each and every component. It's looking at that material. It's then cross-referencing that material to anything in your material library. If there's no material that matches up, then it'll create one. This is the #1 reason why people get the Nesting and Fabrication extension and then don't use it. And it's the idea that they get this far, they're presented with this sea of materials that they don't understand, and then they can't go that next step. And you can see it here, right? Like you've got materials here, for example, 42 millimeters thick. I mean, you can nest on something 42 millimeters thick, but definitely not in this design. And what it's picking up there is, and there's an 87 steel there. It's picking up things like the wheel. So let's look at this caster, right? If I was nesting that caster, it's obviously going to choose this face on the end here as the planar face, the nestable face. And then it's calculating the thickness of the material perpendicular to that. So you're going to end up with rubber that's really thick. And that's going to live in your library forever. Nest preparation is the #1 thing to do before you even go anywhere near the manufacturing workspace in the fabrication tab, because what it allows you to do is go from this list of materials, unmanageable, to something a little bit more like this. So this is the same file, but in this one, what I've done is I've done a little bit of nest prep, and there you go. So we've got a list of materials at consistent thicknesses that I want to use for nesting. I've ignored the casters. I've ignored the handle. I've ignored all the fasteners. I've ignored all of the electronics components within each of these inserts. So the more prep you do when it comes to nest preparation, the easier everything else is. I now know if I needed to change something about one of these materials, let's say one of the packagings, or if I needed to change some of the nest settings here, right? The frame width, the item separation. I know which one to change. In that previous example with that big C materials, you're going to have duplicates in there. You're going to have 5 or 6 2mm thick aluminiums. And now all of a sudden you don't know which one it's going to use to nest. So the more prep you do, the easier everything becomes. And it's not just in terms of the material library. It's in terms of time as well. The opening time of component sources really does go a long way. And I said it affects everything. Let me just pull up component sources here real quick, and I'll show you exactly what I mean. And so what you'll see here is, this is the first time I've clicked it. So what it's going to do is it's going to calculate each of these materials. It's going to calculate the nestable shape of each of these. And then it's going to bring up a dialog that allows me to fine tune each of them. And so whether that be something like modifying the quantity, modifying the material, all of that can be done from component sources. And there you go, you see. So you can imagine that took, let's say, 12, 15 seconds. For the other example, you're looking at like a 2-minute window. And so what you have with the component sources here is the ability to say, well, for this particular component, there's 2mm steel. This is my nestable geometry. I do have the ability to see it in 3D. That's another tip, actually. By default, it's always the 3D view. The most useful view by miles is keep going all the way to the right, and that's going to be your nestable shape. It's going to show you the material grain, the component grain. It's going to allow you to really visualize what that part's going to look like as it's nested. You've got some other parts, other capabilities here as well, overriding the quantity. See, it's picked up 3. It's picked up 3 from the design side. I can modify that. Let's say you've already done a run of this, but you scrapped one of the boards. You can just override that quantity to 4 and really start to make it up. Overrides on orientation. So this is a shortened list, right? This is a list that is only showing me what I want to nest. In the other example, not only does this dialog take significantly longer to open, but it's also, you've got everything there. And now you have to fish through to find the ones that you really want to nest. So it's all about prep. And one final little tip while we're here in the material space is you can sync these materials. So if I go ahead and press sync there, what you're going to see is you can create presets. Those presets are saved within your assets folder. So by creating a preset and applying some of these materials, everybody can use the same materials. And materials are so important because you've got all of these nesting defaults associated with the material. It's used every time you nest anything on that material. So if you want to create consistency between the various different people in your business, in your company, this is the perfect way to build in that intelligence into the chain. So the first one, it's all about nest prep and preparing before you go anywhere near your nest. Anything in the chat, Marco? How are we looking? Anything on YouTube?
No, it's give me 1 second. There's a new one that popped up. Just a tip from Ravi in there. But yeah, no other questions.
Okay, great. Thank you. So tip number 2, reset all. What do we do if everything goes wrong? Hopefully you don't get to that state, but what do we do when everything goes wrong? And let's open up tip number 2 here, a different file. So there's a lot, nesting's a complex process. There's a lot that can go wrong, whether it be something happened to the translation of the file. And what I mean by that is when it starts to calculate the nestable shape, the 2D flattened geometry, it may get itself a little twisted. Maybe you've gone in component sources and you've changed a load of things, right? You've gone in there and you've made some changes to quantities. You've made some changes to various different models. You see, I've derived, using this little plus here, you can add external components into your nest. That's exactly what I've done here. So you see this example, there's no inserts here. My insert is saved externally in another Fusion design. And so what we've got here is I've just hit the plus and I've referenced something in. But let's go ahead and make some changes. So let's override some quantities. Definitely don't want 80. Let's do some multi-selects here. Let's override some materials. Right. I'm in a mess. I can't remember what I've changed. I may have done this 2 weeks ago. What you can do at this point is just do a bit of a reset. So how do we reset? And what do you do when you just don't know where to turn? Well, what you do is you head over to manufacturing models and you see there is no nests. There's nothing within the manufacturing models node there now, but the node exists. And the node exists because you have created and calculated those flat patterns, those nestable shapes. And you did that when you opened the component sources or you opened the material library. So to reset all, to get back to the defaults, right-click on manufacturing models and press delete all. Don't just delete all your nests. That won't work. You got to right-click on that very top level manufacturing models node and you press delete all manufacturing models. What that does is effectively erase all the nesting intelligence and all the nesting calculations that you've done to this point and allow you to start again. So if I now reopen component sources, what it's doing for me at this point is it's saying, well, okay, let me go ahead and calculate the nestable shapes again. Let's start again. Let's rewind a little bit. And what you'll see is that that externally referenced file is no longer there. It's reset everything. And all of my overrides that I made are now gone too. And so I'm back to where I know is works and I can start all over again, which is a really nice thing to be able to do. And so while we're here, I'll show you how you insert those externally referenced parts. So you just something as simple as hitting that little plus, navigate into the file that you want to insert. Let's go here. The audio insert. Let's go ahead and select. So at this point, what you'll see is it's going to say, okay, let me go into that file and let me take all of that nest information and bring it into this file. And now the beauty about nesting and that nest preparation that we talked about in tip number 1 is that everything that you do in nest prep is saved with the design. So all of the parts you ignored, all of the small changes you made to thicknesses is all remembered. And so every time you externally reference that design in from that point, it brings in that intelligence that you did in the file. And so it's only going to bring in the parts and the components that I want to nest. All of the parts that I say to ignore, it just leaves them out. It doesn't even bring them in. I think that's a great touch. And you can tell that a component has been brought in from external. You got this little arrow here that dictates that. Again, another nice touch. And you can start again. So at this point, I could go ahead and create nests. So that's tip again. If you're in a pickle, you're in a corner, you don't know where to turn, right click on manufacturing models, delete all, and you can go ahead and start all over again. Marco, anything in the chat? Any Q&A? Anything on YouTube?
No, we're good right now.
Fantastic. So let's proceed. Tip number 3, Dxf Importer. So we've talked about the Fusion Vision, and we've talked about the Fusion platform. We've talked about how it's an end-to-end piece of software. But everyone knows that it's sometimes you're just going to get some Dxf files that you need to nest, you need to get out the door as quickly as possible. And we've got just the thing. So there's an add-in in Fusion. It's called Dxf Import. Patrick Rainsbury, if you're on the call or you ever watch this recording, shout out to you. You did a great job of creating something called the Dxf Importer. So I'm here in the design workspace, and what I want to do is navigate to utilities. Now, what I've done is I've gone to add-ins. Apologies. I've gone to add-ins and I've gone to the App Store. I've done a search for Dxf Importer, and then I've turned it on in the add-ins area. Now, what that gives me is this little button here on the end, Dxf Import. What this allows me to do is import multiple Dxfs at once and apply a thickness. Now, if I was to do this using native Fusion, I would have to do a insert Dxf one by one by one by one. It's a tedious and laborious process. So the Dxf Importer allows us to expedite that. So let's give it a go. So you click it and it says, well, you've got to select some Dxfs. Well, that's fairly straightforward. I can do that. So you go ahead and press OK. And let's navigate to those Dxf files. And let's hope I can find them nice and easily now as well. Where are we here? Extension onboarding, Dxfs. Here we go. So what have we got? We've got 6 Dxfs here. So I'm going to select them all at once. Go ahead and press OK. Open. And now I've got some settings that I can choose. What distance between the Dxfs do I want? How do I want them to be laid out? All in one line, 3, and then create a new column and a new column. That's what I'm going to do in this case. Do I want to extrude them? And in this case, I do, because I want them in 3D. How far do I want to extrude them by? 2 millimeters in this case. I'm going to apply steel material to them all. And there's a few other options about what I want to do. If there's text in the Dxf, and I can choose the font to bring in. And if I made any changes here, I can save these and it'll remember them for next time. But with that, I'm just going to press OK. And what this is going to do at this point is it's going to look at those Dxf files, bring in that Dxf, and then apply an extrude to that closed profile. And it's going to do that one by one by one and lay them out in a nice, easy to use workflow. And as it does this, it works through them all. And remember, I said 3 number per row. So start a new row at this point. And with that said, I can press OK. And there's my 6 components. And you can see that if I look at the browser, each of these components, it has its own, the structure and the way that it's brought it in makes complete sense. So what I've been able to do there is take a flat 2D Dxf, bring in 6 all at once in a matter of seconds, and apply a thickness to them relatively easily. Now, of course, what you can do is navigate over to manufacture, look to create a nest from them, and away you go. So it allows you to go from flat Dxf and Dxf outline all the way through to the process of nesting. And we're just going to walk through it real quick there. So let's just have 1. In fact, let's have 3 of each. Let's be bold. And I'll press OK. So, of course, I probably need to set up the material a little better, but there you go. So we've gone from lots of individual Dxf files to... In fact, let me go ahead and change that material so you can see the process. So our packaging, let's make it a bit bigger. Let's double the size of this. something like that. And then you can see it's out of, it needs to be updated. Again, another benefit of associativity, and generate it. So now you can see we've gone from 4 sheets to 3, and there you have it. So it's arranged those in the most efficient way across 1, 2, 3 sheets. So the Dxf Imports are there, really allowing you to expedite the process of turning 2D Dxf geometry into nested shapes. Okay, labeling, something new in the last 12 months we added is something called labeling. So let's dive into that. Labeling is the idea that it allows you to track components after they've been manufactured. Let's face it, nesting is a series of often rectangular shapes. And especially if you nest different documents together, different iterations of the same family of componentry, family of designs, you're going to end up with lots of parts that look the same. And we look to address that by allowing users to create what we call labels. And effectively what they are is sticky labels. So it allows the user and all of you guys to use either a normal paper printer with label paper or a dedicated label printer to print out some sticky labels with all the information you need on it to slap on each and every one of these components as it's being cut or as it's already been cut so that you can track it. So how do you do it? Well, it's really simple, nice implementation. What you do is you right click on the sheet. You right click on the nest. So just so you know, and this is another little tip built in, the nest study, think of that as the group. So that's then consumed all the settings you chose when you went and created the nest in the first place. The nest, think of each nest as a material. So nest 18 is going to be a certain material. Nest 19 is going to be a certain material. And if you want to know which is which, nest information is really useful. So if I select nest 18 there, you can see some information about cost. You can see some information about efficiency. I can go ahead and right click on a nest and hit a compare. And what that's going to do is it says 2mm thick aluminium right there. So let me just exit out that edit environment for a second, and we'll show you exactly how to use labels. So how do we do it? Well, we right click on the nest, certain material, and we hit labels. And it's a nice HTML environment. It's going to show you exactly what these labels look like. Now, we've built in some intelligence here into the list of templates so that it's going to give you some common sizes. It's going to give you some common sizes that you can use. So there's a couple of label printers here. So obviously they're going to be in a long one column, lots of rows. But if you're using a standard paper printer, then the template's going to look a little different, and maybe you can fit three columns in, and that's exactly what we've got. So here you can see, I make this a little bigger. You can see that there's this overview label, and then a series of different size labels there as well. And within that dialog, just pull it up one more time, you can print directly over here on the right hand side, or you can save it. And you can save it as a PDF, you can save it as a HTML file. But what it's got is information like the part ID, so the name of the component, the length and width of that component, what assembly it belongs to, what material it's made out of. So all the necessary information is built into the label to easily allow you to see which is which. And that's labels. You do it on each of your nests, send it to your printer as it's been manufactured, and away you go. Easy part tracking around the shop floor. Marco, how are we looking? Any questions?
No, it is clear right now. I know the label was one that had popped up on the previous session. I know one of the comments had left that, so that's good that you covered that one.
Great, it's good to hear. Yeah, labels is a nice addition. Development team did a great work. I know Ravi's on the call. Shout out to the product team and Ravi, the PM. product manager. So yeah, fantastic work and so easy to use, right? Simple right click, just select labels, print it out directly, away you go. So that's tip number 4, labeling. And finally, it's all well and good being able to nest all these things, but how do we take those in a automated way to manufacturing? So let's take a look. And this is the final tip. And it's a good job because my extension is about to expire. So let's take a look at tip number 5. So in tip number 5, what we have is a nest already calculated. And what we want to do is we want to take this nest to manufacture. We want to create some toolpaths. So how do we do that in an automated way? Well, we could create a new setup, select the components, select which nest, but that's all very manual. So what we can do instead is we can right click on either the sheet, the nest, or even the entire nest study and create setups for manufacturing model. So what that button is going to do is it's going to create one setup per sheet. And if you did it on the nest study, you're going to get a setup for each and every one of these sheets automatically. For the purposes of time, I'm just going to do it on one sheet for you right now. So if I right click on sheet number 51, I want to start creating toolpaths. So create setup for manufacturing model. And what that does is it will choose the setup operation type based on your preferences. So it will either be your active tab, and in this case, I'm on the fabrication tab, so it's chosen cutting, or another top tip, if you navigate into your little icon at the top and hit preferences, you can choose the default set operation type. So if all you've got is a laser machine, you'll never need to create any other setup type other than cutting. So to make that your default, and then you're just saving yourself clicks. The other thing it's done automatically is set the manufacturing model, or think of that as the sheet. And it's also brought in the solid body from the sheet itself too. So if you open this up, and I apologize because my mouse keeps double clicking on everything. And if you go to the body, you can see that we've got the stock. That was calculated when we made the nest automatically. And by using that in the setup, it's creating a connection and an automatic connection between the sheet and the setup, but it's also automatically defining your X, Y, and Z of the dimensions. So with that said, all that's left to do is to quickly press OK, and our setup is made. We're ready to go. So at this point, it's all about creating your toolpaths. And that's exactly what we're going to do really quickly. So to do it quicker and to expedite the process, you can create something called templates. So if I right click, I go create from template. I made one earlier today, laser machining KETIV. And what that does is it brings in a whole bunch of toolpaths. This is, again, another instance and another example of the ability to build in some intelligence into the system from one person and let everybody else consume that intelligence. So these 3 toolpaths have all got the tool set up properly. They've all got, if there was any, custom feed set up. They've all got the height set up properly. All of the detail, all of the settings have been defined. All that's left for us to do is select the geometry. And what I want to do in this case is I want to machine the inner profiles all first of every component. So I've selected the face. I hit this little cog. I press select same plane faces. Only press that once. And you can see it's done all of them. Now, all I want is the internals. That's the 3rd little icon here. And so you can see now it's only machining the internal contours, and press OK. And it's going to go ahead and calculate. From there, it's the turn of the outer profiles. So again, let's select our face, press the little cog, select same plane faces. This time it's only the outer, so that's the 2nd icon. and press OK. And last but not least, the remnant cut. There's no remnant cut on this file, so we don't need to do that one, so we can simply delete it. So at this point, what we've done is there's the internals and there's the externals. So it may look like you're basically doing the toolpaths again. All of those other settings, all of the tool and information, all of that built-in intelligence is already in the template. And to create the template, let's say I programmed one of these parts now. I can select them both, right-click, store as template. Apologies, it's on my other screen. Let me drag that across. Give it a name. Save it. And now when I come to do it again, let's delete those two. Right-click, create from template. And there's my sample. And there's my two. So obviously you have to select geometry again. It can't remember geometry. That if I brought this into a different file, that geometry is not going to exist. So the selection of geometry is always needed. But the intelligence that you can build in is far beyond just the selection of geometry. So that's top tip number 5. Use that right-click button to create your setups and streamline all of the downstream creation of toolpaths by using templates. Okay. I can't believe we've got 1 minute left. So quick recap, Ren. So the Nesting Fabrication really does allow you to take your nesting and fabrication capabilities to the next level by external documents and bringing those in to maximize material yield. It allows you to set up a material library and build in that intelligence into the material. So every time you nest in that material, it's going to remember it. It allows you to bring in cost. There's so much more. It's such a comprehensive extension with a whole host of flexible tools to allow you to do what you want to do when you want to do it. And remember, the extensions are flexibly accessed as well. So on the day, monthly, or yearly rate, you can get access to each and every one of the tools we saw today and much, 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 much more. So we talked about, and what feels like a long time ago, is nesting basics, what nesting is and how it works. We touched on what Fusion is, what the vision of the future of Fusion looks like. We then touched on the extensions and why they exist and what extensions are available. We dove into the nesting extension, of course. And then we talked for 5 tips and tricks. Prepare. How to reset all if you get into the pickle. Dxf Importer for importing those multiple Dxf and expediting that process. Labeling to allow you to easily track parts around the shop floor, and how to automate that next step, the manufacturing of the nested shapes. Now, when it comes to manufacturing, something I didn't mention is we can do routers, lasers, water jets, and plasmas, and that's just the 2.5D capabilities. There's also milling, turning, additive capabilities in there as well. So much more. And now I'm going to throw it over to Marco. Marco, any final questions?
We do have one if you maybe want to touch on it. Jerry's asking if Fusion is included in the PDMC and so is Inventor Nesting. Why is the extension still cost extra? I'm not sure if you have an answer for that, or if that's something more for, I guess, how everything's priced.
Yeah, I think so the PDMC doesn't include any extensions, right? But it does include things like Inventor Nesting, as you rightfully say, Jerry. It also doesn't. It includes things like Inventor CAM, right? Manufacturing capabilities, but it doesn't include the Fusion machining extension. It's a decision we made on a packaging level. But of course you do get access to all of Fusion's core capabilities within PDMC. So you could take advantage of a range as well if you wanted to. Not a great answer to your question, Jerry. But yeah, none of the extensions are included in that collection.
Yeah.
Anything else, Marco? How's it looking?
No, that was the only one we had there. I think that is, if anyone has any last questions, feel free to drop them in either in the chat or in the Q&A.
Don't forget the extensions are flexibly accessed too, right? So it's 11 tokens for a day, and you might not need the nesting capabilities for 365 days a year, right? You might just need it when you need it, and that's the whole point of an extension, is to give you that next step, cutting edge, only when you need it in a flexible consumption model way.
Yeah, I think like for Fusion, a lot of the extensions also is accessibility and not even having to run them locally if you can't, or if you don't have a machine that might want to use up those resources. But yeah, I think the token access is definitely useful for a lot of the people that use Fusion.
For sure. For sure. Anything else? Any other questions? Last chance saloon, guys. Anything on YouTube?
No, I think we're good on questions for now. I'm not sure if Christina, you've got if anything else you want to add at the end here.
No, this was great. Thank you so much, Spencer, for joining. And to those of you still on, please be sure to join Spencer and Marco again on June 22nd for the What's New in Fusion 360 session. Same time, same link. Thank you, everyone, for joining. And we will see you all in next week's session. Have a great day, everyone.
Thank you, everybody.